Hi, my name is Julius, and today I'll be talking to you a little bit about sputtering and showing you our sputtering chamber, and then we'll do a little bit of an example so you can get an idea of how the process works. So, sputtering is basically the process where you choose a target material that you want to sputter, and then you bombard it with an inert gas, something like argon, and this material is then ejected from the target, kind of layers onto your substrate to form the film that you'd like to make. So, this is our sputtering chamber. This is very common, and we'll have a lot of common features with anything that you have in your lab. And the important things are the chamber itself, which contains all the things you need to do the sputtering. There's the vat valve in the back, which controls the pressure that is being contained in the chamber during sputtering. A turbo pump in the back, which you can't see, but which maintains the pressure in the chamber, is something on the order of 3 to the minus 10 torr. And then, which you can't see, but on the bottom, the guns themselves, which are connected to power lines and water lines. Here is an inside view of the sputtering chamber. On this side, we have the turbo pump. And the key players in the sputtering process, the 3 guns that you use to sputter, with their gun, chimney, and shutter. I'm going to open up the shutters to show you the targets inside. So over here we have cobalt, here we have copper, which looks pretty characteristically red and pink, and then we have titanium. Today we're going to take our wafer and we're going to sputter titanium as an adhesion layer and then copper. The environment in the chamber is controlled by these power banks here and these controls. The most important one is the mass flow controllers, which feed argon into the chamber, as well as other gases if you want to add things like oxygen or nitrogen to reactive sputter different kinds of oxide films. And then the power supplies, which actually supply the voltage to the gun and the substrate, which then drives the ions to hit the surface. All of these things combine together, the base pressure, the pressure in the chamber, the kind of gas you put in, and the power you apply to determine the kind of film you sputter and the quality of the film that you sputter. All right, just to give you an idea of some of the things you can sputter on top of, we have a polysilicon wafer here as a substrate, as well as a flexible capped-on film that you can also sputter on. Okay, so now I've set everything up to sputter inside the chamber. I've got the power supplied to the gun, I've got argon flowing in the chamber, I've got the pressure set to 3 millitorr, and now I'm going to sputter. So I'm going to go ahead and open the shutter. And you can now see a plasma flowing in the chamber. That's what this kind of glowing light you see is. That's the argon atoms hitting the target material, and then copper being injected inside the chamber towards the substrate. Okay, now the sputtering is completed, so we've turned off the turbo pump and filled the chamber up with nitrogen to allow us to open up again. You can kind of see the seal of the chamber has been breached. So now I'm going to lift it up and you can see where the sample is mounted. And there you go. So on the sample platter is the silicon wafer, and you can kind of see this nice clean pink color, which should look pretty characteristically copper to you. And we're going to go ahead and compare it with the silicon wafer we put in there originally. Okay, and here's the final product. We have the original silicon wafer that we put in there, and this is what it looks like after we put 20 nanometers of titanium and 60 nanometers of copper. And you're done. So now you can use this as a substrate for whatever you want.